Okay. This is the problem, Abby. We've got a truck that's 1.2 times 10 to the third kilograms, moving without its engine on, coasting at 2.2 meters per second. It's coming under a hopper, which is dumping corn into the back of the truck. And it's going to continue coasting, we believe, and we're finding the velocity once the corn has been dumped into the back. So is this the kind of velocity problem where we have two, momentum problem, we have two things on one side and one on the other? Or is it one thing on the left and two things on the right? Which way is this problem lining itself up? Molly?
One on the left, two on the right.
All right, let's see. So you're saying mass, you said one on the left?
Mm-hmm.
So mass, velocity combined, we'll say. On the left, you have to make this decision about every problem. And over here, you're saying mass velocity of the truck plus mass velocity of the corn. Is that what you're saying?
Yeah.
All right. This on this side, the two are separated. Over here, see, the corn is not in the truck, so it should be the other way. Do you see why? They're combined once it fell in, and the problem starts here. So we want mass of the truck, velocity of the truck, plus mass of the corn, velocity of the corn, separate on the left, and together, mass, corn plus truck, velocity, corn plus truck.
Does it truly, and I'm not like questioning your teaching, I'm just asking if it really truly mathematically makes any difference which side it's on. Because they're all positive terms and they're all lined up in the same order.
Yeah, I guess you're right.
I'm just wondering.
All right. Okay, we'll have to try it. Try this one your way, and we'll see. All
Do you
right.
know how much the corn weighs?
The mass of the corn should be known. Let's see what it is. It is given, and it is 7.4 times 10 squared. Thank you. All right. So Molly, you do it the other way, and I think mathematically we'll see. It's just a little theory glitch, which won't matter in the math, I think. All right, filling in numbers for us. Could you do that, Aaron? What's the mass? Just go across with numbers.
1.2 times 10 to the third times 2.2 plus a 0.
Do you notice the corn isn't moving in the beginning? It's just nestled in its hopper, not knowing what's going to happen in a second. All right, so what happens then over here? You don't have to add them, just tell me what you're adding.
I have them added if you'll leave.
No, it's probably clearer if I don't.
So 1.2 times 10 to the third.
That's the truck.
Plus 7.4 times 10 to the second.
To the second. All right. And then velocity of the combined. All right. So when you calculate that, go ahead, tippy tap away. So the velocity, the question is, what is the velocity of the combined truck plus corn once the hopper has dumped the load? What will it be coasting at? It was 2.2. We're expecting something lower. Is it coming out?
Mine came out lower.
What is it?
Mine came out
1.4.
1.4?
Yeah, mine as well.
All right, it's been confirmed. All right, 1.4 meters per second. Is this about yours, Mom? All right, so Molly noticed that she did the combined on the left and they separated them on the right. And as long as you put the numbers in the right place, it doesn't matter mathematically, you'll still get it right. So let's go ahead then, and if you would catch me up. Who's already finished the pink sheet? All right, just 1, 2, 3, 4. Okay, let me give you the next theory that we're going to cross. It's very short, the next theory, and then we'll just close down the class and you can work the rest of the time on the pink, or you can chill, depends which you have to do. So let's finish all our theory. This will help you on the pink. There's one that's very similar to that one, and the rest of them, we've seen examples previously, the skaters, and I don't know what else is back there, but you will. All right, how long do you think we've gone, Brendan?
4 minutes and 52
That's all?
seconds.
That'd be nice if I could just make one video, so. Alright. The rest of this mod is the last topic on the mod, and we're just going to do an open book test that is done with open book and note without a review because it's been very short, and it's also, we're trying to catch up with all the days we've had off. So I think this is a good flyby chapter. So I'd like to do that on Wednesday. So we'll pull some things together, maybe have a lab or something on Monday, a really quick kind of review, not a whole day review. And then, so on Wednesday, we'll have that in class. So that gives you time if you want to read the chapter, if that will really clear up anything that you didn't understand from me. And you got all the way to Wednesday to work on that. And what's the date of Wednesday? 2nd, so you will be here, because Thursday you won't be. Annabelle?
Oh, yeah, that's what I was about to say.
Okay, right.
Thursday.
Alright, we do have 30 minutes of math, but no physics. Alright. The last topic is called angular momentum, so find a new spot on your, is this chalk showing up?
Yeah.
Momentum. Jonathan, do you have this?
Yeah.
Okay. Alright. Angular momentum is probably, it probably teaches itself. That just means that the object, instead of going straight, is going in a circle. So this is circular motion. So angular means circular momentum. We call it angular. You'll recall that in the past we learned velocity was what divided by change in time. Change in what is velocity?
Acceleration.
Nope.
Distance.
Yes, and we called it, we usually used an x, right. So the change in distance. Now if I went change in velocity over change in time, we'd have acceleration. So. Alright, so velocity is change in x over change in time. So we call angular velocity with a this is not momentum. This is just plain angular velocity. We indicate it with the W. So it's the next letter in the alphabet, right? So V is for velocity. That's an old friend. And when we switch it to angular, we call it a W. So that only means the thing is moving in a circle. But what's the velocity of the thing moving in the circle? It's the change in what divided by change in time. Any thoughts there? Not that you're remembering this, you're trying to reason it. What changes when you're going around in a circle?
Is it D?
Pardon?
Would it be D?
Distance?
That part like.
Radius?
Or would it be R?
Which is change in radius? No, not. What is changing when my finger's going in the circle? The radius isn't changing.
The angle.
Right, the angle. So we usually use theta for that. So angular, this is angular velocity. And we won't even be using this, but I just want to show you how similar it is to what we're used to in a straight line. It's almost identical, except the thing is going around. So this is going to follow a similar pattern. Momentum was mv, so we're going to call, what should we call angular momentum? The obvious. Any guesses? What do you guess what letter we use for angular momentum? If we use P for straight momentum.
Q.
Q. Good guess. Wrong. What else? Guess again.
A.
A. Wrong. Who's gonna get it? Guess. Out loud. Everyone start guessing. R. Wrong.
C.
S.
Wrong.
L.
Who said it?
I said L.
L?
L.
Yes. She got it.
Well, that's obvious.
Yeah, seriously.
Alright. She got it.
Angular.
Angular, of course, the obvious.
The obvious answer to the question.
This is angular momentum. It is indicated with the letter L. I don't know why. L equals mv, and the only difference between the old momentum and now that we're going in the circle is the addition of the factor r, which is radius. So what were the units up here? Do you recall, Morgan, what the units were?
For mass.
No, for momentum. It involves
Oh.
mass. Is that
Kilogram.
It was kilogram meters per over second.
right? Remember we didn't rename it?
So this would be kilogram.
Yeah, what's this going to be? Because we added an R. And R is a
Meters
radius. Right. So this was kilograms. This was meters per second. And then we've added another meters. So all it does is kick up the meters to meters squared. And that should make sense to you. What other, I'll make up another one. I'll do grams, centimeters squared per minute. And that would be a legitimate unit for angular momentum. Can you give me one? This is in metric land. Can you give me one in America, in the land of America? What would a typical unit for angular momentum?
Pound foot squared per minute.
Pound? It's not pound because mass is
It's slug.
slug, right? Slug,
Slug foot.
foot squared per whatever, minute or second. Alright, so a slug foot squared per minute or second or hour, whatever unit of time you want to put in there, is a typical unit for angular momentum in America. Got it? Alright. Let's go ahead then and do a discussion and a problem, and that's it for angular momentum. The thing that you need to know is the law of conservation of angular momentum. So we already did the one for regular momentum. The law of conservation of angular momentum. I'm going to write it out, and I'm going to leave some blanks in it. Let's see how good you are in anticipating this law, because it very much parallels the old law. So you can peek back at the old law that we had dictated earlier. If the sum of the blanks, in a system equals 0, then blank momentum does not blank. Alright, fill it in, and if you know what goes in the blanks, you can fill it in as you write that down. So this is the law of conservation of angular momentum. And it's going to parallel the old law that we already studied. How many minutes, or did you already restart it?
It's at 13.
Yeah, go ahead and shut it down.